All right, so in this lecture, I'm going to introduce you to some statistical concepts that you need to know, as well as go over some of the basic math that you're going to need to be familiar with in order to be able to do the statistics that we're going to be learning about. So we're going to start with the statistical concepts, and there's really three important key terms that you need to be aware of. The first is the word variable. And a variable is any observable trait or characteristic that varies within the population. So if you look on this right-hand side here, we actually have two variables. We have height, which is a variable, right? Because we know that it is a measurable trait that varies within the population. And we also have weight, which also is a measurable trait that varies within the population. But other kinds of examples of variables would be intelligence, grade point average, income, household income, gender, et cetera, et cetera. So all of these would be considered variables. The next concept is the idea, the word observation. And in this case, an observation refers to a single individual standing on a particular variable or a trait. We would also consider this a data point. So at this point here, this is a single person, and we have plotted their height against their weight. So this is someone who is slightly under 5 feet tall and who weighs about 100 pounds. And then we have this person here, another individual who is, let's see, sort of getting closer to 6 feet tall and who is slightly over 100 pounds. So maybe they're 110. And so each one, so when we refer to an observation, what we're really referring to is a single data point that's being generated by a single individual. Right? However, we also might want to refer to data or a data set, and that's a set of observations from a sample of participants. So where each of these dots represents a single person, this set of dots, right? So data from a group of individual is referred to as data or a data set. So the next thing we need to think about or know about are types of variables and scales of measurement. So we can have two different kinds of variables. So even within quantitative research, we have both qualitative and quantitative data. So qualitative variables differ in kind. So an example of a qualitative data point or qualitative variable would be gender identity. So it could vary man, woman, non-binary, for example. Another example would be race. So anything that can be sorted into categories or varies by kind would be considered a qualitative variable. All right. Any numbers that get used are simply used to represent the categories and cannot be subjected to mathematical operations. So for example, we might use the variable gender identity, but in our SPSS database, we might assign 1 to man, 2 to woman, and 3 to non-binary. Within the qualitative data variables, we have nominal and ordinal variables. So nominal, like its name implies, is strictly categorical, right? So gender and race would be considered nominal qualitative variables. Within nominal, we can have both binary or categorical. So binary, as its word implies, means that it is a variable that has two different categories. In medicine, a lot of times, we might have two outcomes. The person survived or they didn't. The person recovered or they didn't, right? So those are two discrete categories. You can only fall into one, and that's a really important part of these categorical variables, is the person can only fall into one category and they have to be exhaustive. So they're either binary or they're categorical in the sense that there's multiple categories, and so gender identity would be considered a categorical variable in the sense that there are more than two more than two categories. Race would be considered categorical. The key is that when we design a nominal variable, we need to make sure that we have an exhaustive list so no one looks at it and says either I'm not represented by the categories here or I'm represented by more than one. Okay. The other qualitative variable is ordinal. The other scale of measurement that falls within the qualitative variable type is ordinal, in that its rank orders information, right? So an example would be first, second, third, or heaviest to lightest. And then again, numbers associated with the categories are more meaningful because they do represent a certain order. But the difference between the values is not the same, right? So the difference between first and second place in a race could be larger than the difference between second and third place, right? So if we think about like the Olympics, sometimes the difference between the first and the second place runner could be less than a second, and maybe the third place runner comes in 20 seconds later, right? So the distance between those numerical variables varies quite a bit. The other thing is these numbers can't be subjected to mathematical operations, because what does it mean that people came in on average fifth place, right? So generally speaking, we don't use it for that purpose. Okay, the second types of variables are quantitative variables, and these are variables that can be subjected to mathematical operations, and so these are the kinds of variables that we're going to be interested in when we run our analyses. Although I will say that when we use something like a Likert scale, which sort of falls within the area of ordinal, we tend to be a little bit looser on that. The purists would say you can't use those kinds of scales. You can't analyze those kinds of scales statistically, but a lot of researchers do, and we'll get more into that as we move along and talk about measurement more specifically. So in an interval scale of measurement, the difference between two values is the same. So the difference between 2 degrees Fahrenheit and 4 degrees Fahrenheit is the same as the difference between 80 degrees Fahrenheit and 82 degrees Fahrenheit. However, because there's no true zero, right? There's no absence of temperature. It's not possible to make ratio judgments, right? So 2 degrees Fahrenheit is not half as warm as 4 degrees Fahrenheit. And that's because there is no true zero. And by that we mean that there is an absence of the trait. So any interval scale, if it has a zero, the zero doesn't represent absence of the trait. Whereas in a ratio scale, the distance between the values is the same. And zero is a true zero in that it represents lack of a trait. In this case, then, ratio judgments can be made, right? We can say that in height, 4 feet is twice as tall as 2 feet, right? And that's because we can also have 0 inches of height, meaning there's absence of the trait. Within that, we can have discrete or continuous variables. In discrete quantitative variables are expressed only as whole numbers. So 1, 2, 3, 4, 5, right? There's no divisions in between, whereas a continuous variable can be broken down into ever smaller gradations. So this, in a continuous variable, we will also have decimal points. Okay, so we can't have, when we count people, for example, people are whole numbers, right? We don't consider there to be a half a person. However, we might think about pie, counting up pies, we can have half a pie, a quarter of a pie, or a full pie, right? So in that case, that would be considered a continuous variable. Same thing with height, right? That people don't necessarily fall perfectly at a whole number. They might be 5 foot 3.5 inches or 5 foot 3 3/4 inches. Okay, and so that would say height is a continuous variable, whereas the number of people in a room would be considered a discrete variable. All right, the next thing that we need to remember is how to do mathematical operations with signed numbers. So this is just a reminder. You guys have learned about this a long time ago, but it's amazing how easy it is to forget this stuff when it's been a long time. So when you're adding or subtracting signed numbers, there's a series of steps that you should do. The first thing you should do is add up all the positive numbers. So in this formula here, we have 5 minus 4 minus 3 plus 2 plus 6 minus 1. So the first thing we want to do is add up all the positive numbers. 5 plus 2 is 7 plus 6 is 13, so we have positive 13. We then want to add up all the negative numbers. Minus 4 plus minus 3 is minus 7, plus minus 1 is minus 8. We then want to subtract the sum of the negative numbers from the sum of the positive numbers. So in this case, we would subtract 8 from 13, and we would get 5. So that's just an important thing to remember. When we're multiplying and dividing signed numbers, okay, when we multiply and divide two numbers with the same sign, the result is always positive, right? So 5 times 6 is going to be equal to 30. Minus 4 times minus 8 is going to be equal to positive 32, right? However, if we multiply or divide two numbers with opposite signs, the result is negative. So for example, minus 5 times 6 is going to be minus 30. When we multiply or divide an even number of negative integers, the result is going to be positive. So minus 2 times minus 2 times minus 2 times minus 2 is going to be plus 16, right? Because we get minus 2 times minus 2 is 4, times minus 2 is minus 8, times minus 2 is plus 16. Whereas if we multiply or divide an odd number of negative integers, the result is going to be negative. Right? So minus 2 times minus 2 is equal to 4, times minus 2 is equal to minus 8. All right, and this is important because we're going to be doing mathematical operations that may involve negative numbers, and so we need to be able to remember exactly how we should go about adding or subtracting, multiplying or dividing them. The next thing that you need to know about are proportions and percentages. So proportions represent the portion of a specified group that meets a certain criterion. Okay, so what part of the whole meets a certain criterion? Like what part of, or how many students in the university, or what portion of the students in the university identify as non-binary? What portion of the students in the university identify as Black, for example? And proportions are expressed as a fraction. So for example, 2/10, or as a decimal, for example, 0.2. And just as a reminder, to change a fraction into a decimal, you simply divide the numerator by the denominator. So 2 divided by 10, you get your decimal point, and you multiply that by 100. Divide the numerator by the denominator, and that's going to give you your decimal, right? So 2 divided by 10 is going to give you 0.2. Percentages are really just another way of expressing the same information, but we're now using, instead of expressing them as decimals, we're expressing them as whole numbers. So we take the decimal, multiply it by 100, add a percentage sign, and that gives us percentages. But it gives us the same information, right? So 0.2 times 100 is 20%. All right, I'm going to end here and then start up again on the next video.